In this video we're going to look at some of the other types of number sequences that can be asked, and the first one we're going to look at are quadratic sequences. So these are slightly different to linear sequences. Okay, the first thing we're going to do is take a look at this and see if we can figure out what this term will be. So we have term 1, we have term 2, we have term 3, we have term 4, but we don't have term 5 or term 6. Well, it should be straightforward, shouldn't it? Well, let's have a look. The difference between 2 and 15 is 13. The difference between 15 and 36. Now, how am I actually doing this in my head? I'm getting the bigger number, by the way, and I'm taking away the smaller number. That's 21. So the difference there is 21. The difference between 36 and 65, let's do that down here, 65 minus 36, that is 29. So I have a problem, because what is this one going to go up by? If you look at our differences that we found, none of them are the same. 13, 21, and 29. So the question is, what is this difference going to be? And hence the reason why this is not called a linear sequence. They're the ones we did in the last video. These are a little bit different. These are different because the first difference that we just found are not the same. So it's a little bit harder to predict what is coming next. Now, in order to do this, in order to find what this is, we need to find what's called the second difference. We're going to do that in red pen. The second difference is the difference between the differences. Okay? So what's the difference between 13 and 21? It's 8. And what's the difference between 21 and 29? That's also 8. So what would the difference be between 29 and this number? 8. And that's going to help us get this number, which in turn will help us get this number. Okay? So if the difference between 29 and this number here is 8, well then this number must be 37, which means it's 65 plus 37, which is 102. Now, to find term 6, it would be the same. I'd need to first of all work out what it's going to be 8 here, up to this number here, and then another 8 onto the next number, up to this number, a little web. We'll worry about that in a minute because we're getting a bit complicated there. Let's just figure out what quadratics are first. If the second difference, now the second difference were these numbers that I found down here. This is the second differences. These were the second differences. If they are the same each time, then we call it what's called a quadratic sequence. Okay, so this up here, this example that we've been doing, this one here, this is a quadratic sequence because the first difference are not the same, but the second difference, they are all the same. And that makes it a quadratic sequence. Okay? And you can now find the next terms in the sequence using this information. So I don't want to overcomplicate it by finding this very last term yet. Let's just be happy with, we'll do that in the second example. Let's just be happy if we can understand where we got term 5 from. Let's just go over that again. So I didn't have this, by the way. I didn't have 102, and I did not have 8, and I did not have 37. All I had was 2, 15, 36, 65. I found the first difference, first of all. So that's the difference between these numbers. I got 13, 21, 29. Then I found the difference between these differences. So what's the difference between 13 and 21? It's 8. And what's the difference between 21 and 29? It's also 8. So that means that here should also be 8. So the difference between 29 and the next difference is also 8. So I have to add on 8 to 29. That gives me 37. So now I know that 65 plus this 37 will give me what goes in here. That's where I got my 102 from. Okay, see how it's done? Let's try another example. So in this example, I've been given term 1, term 2, term 3, term 4, term 5, all the way up to term 6, but I haven't been given term 7. And I need to find it. Okay, what do I do first? I find the first difference. That's the difference between these numbers. 5 and 9, 9 and 15, 15 and 23, 23 and 33, 33 and 45. Okay, what's the difference between 5 and 9? Remember, get the second term and take away the first term if you're not sure. It's 4. Now, what's the difference between 9 and 15? It's 6. What's the difference between 15 and 23? It's 8. That's 10. That's 12. Okay. Now, let's get the second difference. Let's do this in red. Remember, if this is quadratic, the second differences will all be the same. So let's see. What's the difference between 4 and 6? 2. What's the difference between 6 and 8? 2. What's the difference between 8 and 10? 2. What's the difference between 10 and 12? 2. Okay, so it's definitely a quadratic sequence. Now, I'm asked to find term 7. So I need to use this information that I found to work out term 7. And funnily enough, you kind of have to start down at the bottom. I know the difference between 10 and 12 is 2. So the difference between 12 and this next number will also be 2. So this next number up here must be 14, because 12 and 2 is 14. Now I know that 45 plus 14 will give me term 7. So term 7 is 59. Okay, see how I did that? Okay, they're called quadratic sequences, and I'll come back to them in a moment. Let's look now at exponential sequences, and this is the last type of a linear number sequence. We've looked at linear in the previous video, we've just looked at quadratic in this video, and now this is the last type, exponential, and it's very straightforward. Take a look at this sequence here, and let's see if it's linear. So let's find the first difference. The difference between 4 and 8 is 4. The difference between 8 and 16 is 8. Okay, so it's definitely not a linear sequence because already these first differences are different. The difference between 16 and 32 is 16. And the difference between 32 and 64 is 32. So let's get the second difference. Seeing as how we just worked out the first difference, now let's find the second difference, and maybe then we'll see that it's a quadratic. Let's do the second differences in red. So the difference between 4 and 8 is 4. Between 8 and 16, is 8. And between 16 and 32 is 16. So neither the first or the second differences are the same. And when the first or second differences are not the same, it means it's an exponential. It probably is an exponential sequence. Now, what does that mean? A sequence of numbers that involves doubling or tripling is called an exponential sequence. Okay, so let's check if that's what's going on here in our sequence. We've got 4, 8, 16, 32, and 64. Right, are they doubling these numbers? What's 4 multiplied by 2? It's 8, isn't it? And what's 8 multiplied by 2? It's 16. And what's 16 multiplied by 2? It's 32. What's 32 multiplied by 2? 64. So it's actually an exponential sequence because the numbers are being doubled. Okay, and if they're doubled, or, when we look at it in a minute, a tripled, that means it's an exponential sequence. The first difference or the second differences are not the same. So it's not linear, it's not quadratic, it's an exponential sequence. Okay, what would this next number in the sequence be? Well, it's going to be 64 multiplied by 2, isn't it? So it's going to be 128. In some ways, these are actually easier than quadratic, because it's either involving doubling or tripling. Okay? Here's another example. Let's see if you can figure out what's going on in this one. I'm going to pause the video if you need to. Have a look at that and see if you can figure out what's going on. I'm going to keep going. Okay, I'm going to find the first difference. Here's the first difference. I'm going to do it in purple. So the difference between 3 and 9 is 6. The difference between 9 and 27 is 18. The difference between 27 and 81, oh God, is 64. And the difference between 81 and 243 is 162, I think. Okay, definitely not linear. Now let's do the second difference in red. That's the difference, remember, between the differences. So 6 to 18, that's going up by 12. 18 to 64, that's going up by 46. No, it's not quadratic. Okay, because if it was quadratic, the second differences would be the same. And they're not either. So we're going to need to rub out all of that. That's all meaningless. So it must be an exponential sequence. Now remember, exponential means it involves either doubling or tripling. Okay, so let's see. 3 multiplied by 2 would give me 6. That's not 6. Okay, so it's not doubling. Is it trebling? 3 multiplied by 3 is 9, yes. And 9 multiplied by 3 is 27, yeah. And 27 multiplied by 3 is 81, yeah. And 81 multiplied by 3 is 243, yeah. Okay, now I know what to get in here. I multiply 243 by 3, and I get 729. I did that in my head, now I'm not sure. Yeah, I think that's right. 729. Okay, so just to recap now, right? We've done 3 types. Number sequences can take 3 forms. And over the course of the past couple of videos, you'll have seen these 3 forms. The first form is linear. They're the most straightforward, okay? So, what is a linear sequence? It's when the numbers go up or down, they can go down as well, but by the same amount each time. And here's an example. 2, 5, 11, 14. So I just take a look at that and I get the first difference. What's the difference between 2 and 5? 3. What's the difference between 5 and 8? 3. What's the difference between 8 and 11? 3. What's the difference between 11 and 14? 3. So that's an example of a linear, because the first differences are all the same. Then you know it's a linear sequence, alright? Now earlier on in this video we looked at quadratic, okay? Quadratic, that means it's when the second differences are the same each time. So let's get the first difference of this sequence here. 2 to 4 means you went up by 2. 4 to 8 means you went up by 4. 8 to 14 means you went up by 6. And 14 to 22 means you went up by 8. So none of those are the same, so it's not linear. But look, when I go and find the difference between these first differences, difference between 2 and 4 is 2. Difference between 4 and 6, 2. Difference between 6 and 8, 2. The second differences are the same. That's how I know it's a quadratic sequence. So the second differences are the same. That's a quadratic. And then finally, the one we just looked at, exponential sequences. Neither the first or the second differences are the same. Instead, the numbers are doubling or trebling each time. So I would try and see if it's a linear first. Let's see if it's linear. 5 to 10, you went up by 5. 10 to 20, you went up by 10. Okay, it's definitely not linear. 20 up to 40, you went up by 20. 40 up to 80, you went up by 40. Now let's get the second differences. 5 up to 10, you went up by 5. 10 up to 20, you went up by 10. No, the second differences are not the same. So it means that it's definitely not quadratic either. So now it must be exponential. And yes, when you look at it, what's happening with those numbers? 5 times 2 is 10. 10 times 2 40. Okay, hope you know the three.